In the last video, I defined what a recursive language model is. In this one, I want to make that concrete. Because at a system level, this isn't abstract. It's a set of interacting loops. And how those loops are structured determines whether the system stabilizes or drifts. At the center is a loop. Generate reasoning, evaluate that reasoning, modify it, and run it again. That's recursion. But in a recursive language model, that loop is not open-ended. It's structured. Every iteration is evaluated before it continues, not just for correctness, but for alignment with constraints. That means that the system isn't just asking, is this output valid? It's asking, should this output be allowed to shape the next step? That's a different question. The system doesn't allow every possible reasoning path. It restricts what kind of outputs can be carried forward, what kinds of reasoning are acceptable, and what gets rejected entirely. This is what turns recursion into structured recursion. Then you have iteration control. The system determines when to continue refining, when to stop, and when additional passes no longer improve the result. Without this, recursion becomes open-ended and unstable. What matters most is how these pieces interact. Evaluation without constraints doesn't hold. Constraints without iteration don't improve. Iteration without limits doesn't stabilize. It's the combination that creates coherence. So when you combine recursive reasoning, structured evaluation, constraint enforcement, and controlled iteration, you get a system that can refine its outputs without losing alignment over time. And that's the key difference. Recursive language models aren't just looping systems. They're systems where the loop itself is governed. So improvement doesn't come at the cost of stability. It becomes part of it.